Now we're going to look at serial and parallel interfaces. So imagine you've got two devices, one device here and another device, and they're having to transmit data to each other. Now in a serial interface, we've got just two lines. One line's for data, and the other one's read, write. Okay, so you've got a data line in which the data will go from one device to another, and this is just to say whether it's reading data or if it's writing data. So what actually happens is, imagine we're going to write data, or data is going to go from this device to this device. What would happen, I'll get another colour pen, the binary just queues up, okay, so it only sends it one bit at a time, and this line changes to write. So that device knows it's going to write data to this. Okay. So what then happens is each of these digits go one bit at a time. Okay, so it's rather slow, but it's good for long distances. Okay, because it does one at a time, so there's no confusion. So this is a serial interface, so it's good for long distances. But since it is one bit at a time, it's slow data rate. Yeah, so that's your serial interface. Now, there's another way of doing it, and this is using parallel. So, right, so with parallel, they actually use 9 lines altogether, 8 for data, and 1 to see if it's a read or a write. So you use 1, 2, 3, 4, 5, 6, 7, 8, and the last one is just to see if it's read or write. Now, if I even this up, imagine you've got data being sent from left to right. Okay, so the first 8 bits are waiting to be sent. Okay, and there's a write. Now behind that there's another 8 bits. Okay, so I'm just randomly choosing 8 bits. And behind that there's another 8 bits. Right, so obviously with this method you can actually send 8 bits at a time, or a byte, and you can actually have more than 8 lines. Okay, so with serial you can only send 1 bit at a time. With this you can actually send 1 byte at a time. So what happens is, the write means that each one of these binary digits gets sent along the cable, each wire at the same time. So it's like looking at somebody or a group of folk doing 100 metres. They're not going to all finish at the same time. So what might happen is this reaches end, so does this one. This one's slightly behind. This reaches it at the same time. These ones are slightly behind. Okay, once these ones have been sent, then it's time for the next ones. So the next one's sent there, there. Now I'm not going to do this for them all because it'll take a wee bit too long. But I'm just needing to do it for the first lot because hopefully you'll start seeing if they're coming out at the same time. It's quite hard to see. Is this one set of binary digits all belonging to each other, or how does it know if it's maybe from the byte after it, or even the byte after that? Okay, so if you're using parallel interfaces, it only works in short distances. So this is why when I showed you the wee cable inside the computer, the ribbon cable, this is why you'd use it, because over long distances each digit doesn't come out at the same time, okay, and that can confuse the system because again it doesn't know if all these digits actually belong to the same byte or not, and this is called skewing. That should be a K, right? So that's called skewing. So if they all come out not quite at the same time, that's called skewing, and that's really the downside. Good for short distances, and it's faster data rate. So it's good for transferring data really quickly, but if it is a long cable, you start getting problems with this. So it's not good for long distances. So that's why it's really peripherals that are close to the actual CPU. And that is serial and parallel.